Well, hello. Today we are going to be continuing our endeavor to learn more about decimals by dividing them. Now, before we get into actual decimal division with all different kinds of decimals, we're going to be looking at primarily dividing by powers of 10. That's because it's much easier to divide by powers of 10. So, one of the things we can do is if we're dividing by 10, we could say, okay, well, let's write things as a fraction. So we could say this 423.5. That's the same thing as 4,235 divided by 10. Remember, that's that idea of if we just have to move this over. This is the tenths place, so this is over 10. Then, if we're dividing by 10, that's 10 over 1. Remember that idea of keep the first, change the sign, flip the second. Keep, change, flip thing. So then we'll end up with 4,235 over 100. And then remember, if we're dividing by 100, that means we need to have two decimal places. We have hundredths. So that's where this comes from. Now, we're not actually going to do that with all of these because there is kind of a shortcut. Just like with our multiplication, when we figured out, well, if we have two zeros, we would move the decimal to the right two places. Well, if we have two zeros and we're dividing, we're going to move the decimal in the other direction. So we'll move this two places to the left. This actually comes out as 4.235. Okay? So because this is 100, because we have two decimals, we're going to move 2 to the left. Okay, so keeping that in mind, over here we've got 1,000. Think about this. If I have 3 zeros here, then what I'm going to do is actually move 3 places left. That's what we'll do with our decimal. So we're going to take this decimal and go 1, 2, 3 places to the left, and we get 0.4235. And again, we usually put that 0 right out front. Okay. Here you can look and see that we've got 4 zeros, so we're going to move 4 places. And if we're dividing, it means we need to make the number smaller. We got to move that number to the left. So we go 1, 2, 3. Oh, we ran out. I've got to actually move it more than just what I have. So that's how I'm going to end up with 0.04235. And I'll put that other 0 out front. See, now you can see that if we move it 4 places, 1, 2, 3, 4, we would actually need another placeholder right there. And then, of course, this next one, we're just moving 5 places, right? So this should be 0.00423 5 for that. Okay. Same idea as what we just got done doing above here. For some reason, my computer likes to jump around. Here we've got 10 squared. That's the same thing as 100. And you can still see that because we have we have a power of 2, we'd be moving it 2 places. So 34.506 would be our answer. Here we've got 3 places, so we'll move it 1, 2, 3. That's because we're dividing by 10 to the 3rd power. So 3.4506. 10 to the 4th power, we move it 4 places. Go ahead and count them out there. And we get 0.34. Man, my computer today, I'm sorry. It's just being weird. 0.34506. All right. And then this next one, when we move it all 5 places, we actually end up going 1, 2, 3, 4. We've got to go even past that, so we get 0.034506. Okay. So that pattern is just this idea of moving the decimal to the left the same number of zeros that we are going to be dividing by. Okay. This next page that we have in our notes, this just has a whole bunch more examples of everything we just did. So if you didn't quite understand that, then go through and look at these because it's a whole bunch more of just recounting that whatever you're dividing by, that's how many places you're moving the decimal. And then ultimately, you should do these. Pause the video right here. Make sure that you can do some of these divisions because these are the easier ones before we get into the hard ones. Okay, let's get our answers put up. We'll move this decimal 2 places so I get 0.0359. Over here, we're going to move it 4 places so I get 0.006479. Down here, I'm going to move it 2 places because I have 2 zeros, so we go whoosh, whoosh. I get 6.234. Okay, so just 2 places like that. And the last one, we're moving it 3 places, so 0.009407. Okay. All right. Now we're going to actually look at dividing numbers that are not just powers of 10. So first, we're going to convert everything into fractions, and we're going to build from there. We're going to build from fractions and then eventually get to this conventional idea of dividing with decimals. So let's first take a look at dividing some whole numbers. Most people are pretty good at dividing whole numbers. You would think of this as 24 over 1 divided by 8 over 1. That's like saying 24 over 1 times 1 over 8. And of course, that's just 3. So those are some nice whole numbers. But let's consider what we have over here. This is 2 4/10, or in other words, 24 tenths, divided by 8/10, right? 8/10, like this. So what we're going to do is we're going to flip that second one. 24/10 times 10 over 8. And then ultimately we can do some canceling. We get 24 over 8, which comes out to be just 3. All right. So 24 divided by 8 is 3, and 2.4 divided by 0.8 is also 3. Okay. Well, let's keep going. What about, let's go back to some nice whole numbers here. 240 divided by 8, that's 8 goes into that 3 times and then another factor of 10, right? So it goes in 30 times. But this is a little bit weirder. So let's look at this one. Of course, I can take this 24 tenths, and then this says 8 hundredths. So we'll do that. Then this gets flipped so that we have 24 tenths times 100 eighths. Now let's do some reducing. Those cancel. And now I've got, oh, I can also cancel here and here too, right? There we go. 3 times 10 is 30. Now this seems very strange until you actually almost put a context to it. You might be thinking like, wait a minute, how did we start out with 2.4 and we ended up with 30? How did we get such a large number? Well, think about it like this. What if you have $2.40 and you're buying some candies that are 8 cents each, right? What if you're buying some things that cost 8 cents each and you have $2.40? Like, how many candies could you buy? Probably quite a few of them. If they're only 8 cents each, you can actually buy 30 of them. So even though we started out with a small number, and you say, how can you take a small number, divide it, and get a large number? Well, it's because you're actually dividing it into teeny tiny little parts, right? This, we think of this almost like $2.40, but what if we changed it into 240 cents and we're buying candies that are 8 cents each? Oh, kind of like this over here. Right, dividing by decimals doesn't always make sense, but dividing by nice whole numbers kind of makes sense. So let's maybe start thinking about it that way. 39 divided by 13 is just 3. Over here, I could take and change this into 39 tenths times, well, we'll do divided and then we'll flip. So 13 tenths. Then what we're going to do is flip those over. And we get 39 tenths times 10/13. Some canceling happens. I get 39/13, which is still just 3. Okay, so ultimately I ended up moving, just kind of like moving the decimal one place. Down here, 390 divided by 13 comes out to be 30. And this is much like the problem we just did with our candy as well, right? If I have 39 tenths, and I want to divide that by 13 hundredths, ultimately what I'm kind of doing is I'm saying, you know what, I don't like dividing by decimals. Let's just convert these into whole numbers. So if I want to change these from hundredths, or in other words like dollars into pennies, we could say, well, we'd have to move this decimal 2 places, right? So that we'd be dividing by 13. And if I move that 2 places, I can move this one 2 places as well. So as long as I do the same thing to both of them, I'll be fine. That's going to end up still getting me 30 because I just turned it into this original problem. So here's the pattern that we're going to do is we want to move the decimal to the right the same number of times on the first and the second number. Now you might be wondering, well, how in the world, like how many, am I just supposed to move it to the right like 10 times, or do I move it to the right till neither one of them has a decimal, or what? Nope, you do it until the second number is a whole number. That's what you do. We want to say, well, we want to turn this number into a whole number. We want to divide by whole parts. So if we're going to move this 2 places to the left, then we got to move this one 2 places to the left, right? If we only need to move it 1 place to the left, like that, then we're only going to move this one 1 place to the left. It's actually okay to have a decimal still left over in the first number. It's the second number that you want to turn into a whole number. Now, what that does is that leads us into conventional decimal division. Okay, and here's a nice little picture. You can do some reading on this if you'd like. But you can see that what we're looking at here is, well, let's start up here. What we're looking at with this one is we actually have to move the decimal 2 places. We're going to move it 2 places to the right in order to make sure that we have a whole number here. So if we move that 2 places to the right, then we got to move the first one 2 places to the right as well. That's how we end up getting this 485 on the outside, and on the inside we have 2,958.5. So we saw that we had to move it 2 places, so we moved it 2 places on the inside and the outside. Okay? That's decimal division for you. Then what you do is you take this decimal, whatever it is, and you just bring it straight up. I know it doesn't, this one's kind of diagonal, I'm sorry. But you always just bring that decimal straight up and then keep track of everything else after that. Okay, let's do a few of them together. Of course, here's some nice work. You can see they keep everything lined up. This decimal right here, that's this one right here. They just brought it straight up. And they figured out how many times 53 went into here. We did some multiply, subtract, all that stuff. Okay, so that's nice work. Now let's you and me work a couple together. Don't make me do all the work here. Make sure you're doing it too. All right, so we've got 5.64 divided by 6. And when I go to write this in long division format, I'll have 5.64 divided by 6. Okay, so the first thing that I'll note is that this is not a decimal. Because this is not a decimal, I don't have to change anything around. I'm just plenty good just like it is. So I'll take this decimal and write it right up here on top. I'm not even going to move it. You always just straight up top. Okay, does 6 fit into 5? No. 6 goes into 5 0 times. Does 6 go into 56? It sure does. 9 times. So we'll multiply that 9 times 6, and you just kind of forget about this decimal here. Okay, just kind of forget about it. And we've got 9 times 6 is 54. 6 minus 4 is 2. Bring that next one down. And then 6 goes into 24 4 times. Of course, it does fit perfectly, so we're done, and we just end up with 0.94. Okay. Now the next one here, whenever I go to write this out, I'm going to have 40 divided by 0.8. And so the first thing I see is that this has a decimal, right? We've got to move it 1 place to the right. So I've got to take the decimal that would be here. There's no decimal written here, but we like pretend that there's one here. We take that decimal, we've got to move it one place to the right. So that ultimately what I get is actually 400 divided by 8 instead of 40 divided by 0.8. We move that one to the right here, so therefore we got to do it there. Now, 8 doesn't go into 4, it does go into 40, 50 times. And then we bring the next one down. And now that's just 8 goes into 0, 0 times. So 8 goes into 450 times. Now we could verify that's right, because if you look back at the original, we say 40 divided by 0.8 equals 50. Well, if we go the other way with multiplication, that's true if I were to say 50 times 0.8 equals 40. Right, because multiplication and division are inverses of each other, so we should be able to do the opposites to undo things. So 40 divided by 0.8, I got 50. Now maybe I wasn't quite sure about that. So if I actually take the time and I multiply 50 times 0.8, well, I just do some multiplication here, and I notice I have one decimal, so I've got to have one decimal in my answer. I get 40.0. Yeah, 40. So we just double checked it just to make sure that it's right. Okay. All right, look at this. You can even see the end. That's the end of what we're doing here. We've only got 4 more division problems to do. Okay. A little long division here. 6.515 divided by 5. You'll notice that nothing needs to change on this because this is a whole number already. If it wasn't a whole number, then we've got to move some things around. We don't have to. So I'm going to, first of all, bring my decimal just straight up, right where it belongs. And I'll say 5 goes into 6 one time. 1 times 5 is 5. Subtract. I just ignore this one now. We're not concerned with it. It's a part of the answer, but not for what we're doing here. 5 goes into 15 3 times. 3 times 5 is 15. We bring the next one down. This one's a little bit interesting because 5 doesn't go into 1. And a big thing here is that there's a lot of people that tend to forget that if 5 doesn't go into it, I still have to put a 0 and say, hey, look, it goes into that 0 times. Now we can bring the next one down as well, and we would say 5 goes into 15 3 times. Of course, it does go in perfectly. There's nothing left over. We're done. 1.303. Okay, now they're going to start to get a little bit uglier. Nobody likes doing these. Well, there's probably somebody out there. If it's you, then cool. You should leave a comment. Be like, I love doing this. Okay. But here's kind of the whole crux of our lesson today, and that is that we've got to move this over 2 places. So if I do this out front, I've got to do it here as well, and I'm going to rewrite it so I have a little more room. This turns actually into 46 on the outside and 128.8 on the inside. See, we had to move this over 2 places here, so we move this over on the inside as well. Now, just put that right up there. And I would say, how many times does 46 go into 1? Nope. 46 into 12? Nope. 46 into 128? Yes. Now, you might be tempted to say 3 times, because I know 3 times 4 is 12, but that won't work on the back end. It's just going to be 2 times. So 2 times 6 is 12. That's going to be 9. Okay. And I get 36 left over. Then I bring the next one down. Okay. Now, if I had gotten a number bigger than 46, all that means is I'd have to come back up here and change this. I'd probably have to bump it up 1 to 3. Okay, so this number always has to be smaller than what you're dividing by out here. Okay. So now we're going to say 46 into 368. I'm going to just take a guess and say it's like 8. My initial thought is 9, because 9 times 4 is 36. But there's, man, I've also got to do 9 times 6 here. So I'm going to guess 8. 48. That's 32. Oh, good. It went in evenly, perfectly. Done. 2.8. Now, once again, you could check this out easy enough by taking 2.8 times 0.46. And let's just do this quick check here just to make sure I'm right. So that's 48, 4, 16. I talk to myself a lot. Right now I'm talking to you because you're listening, but unless you muted me. Okay, so I got this. Then I come back up here. We learned that when we do metric or when we do decimal multiplication, we just count how many decimals we have. 1, 2, 3 decimals. So I better have 3 decimals in my answer. 1.2888. 1.288. Okay. So yeah, look, if we multiply these two together, then we end up back where we started. That's how we know it's right. It's definitely right. Okay, 2 more to go, and these are not attractive problems. That's okay. We like them anyways. They've got good personalities. So this is 7385. We know the decimal would be there. And we've got 9.6. And what we're going to have to do is we're going to have to move this over one place here on the outside. So I'm going to move it over one place here on the inside as well. So this actually turns into 738.5 divided by 96. Right, I moved this one place, so that means I had to move this one place. We'll just pop that decimal straight up above. And now we've got to start trying to fit 96 in here. So 96 doesn't go into 7, doesn't go into 73. It will go into 738. Ooh, probably 7 times. Let's make a guess of that. 42. 63 and 4 makes 67. Now when I subtract these, if I get a number bigger than 96, it means I better bump this up one. All right, so that's 6, and then 6. Looks like we're there, I think. Okay, so we've got that. Now we're going to say, let's bring the next one down. Put the 5 there. And now we got to figure out what goes into this. Now here's the thing. I know that 7 times 96 is 672. I'm trying to get 665. So 672 is clearly too big. Must be 6. So if I put a 7 here, I'd get 672. That's not going to fit. Right, so that's 36. Well, now we have a 3. 9 times 6, right? I got to take this here. That's 54. And 3 more makes 57. 576. Okay, we'll subtract those. I think it comes out to be 89. So I was thinking, let's take this up to 600. So I'd plus 24 to get up to 600, and then plus another 65. So I know that's weird, but sometimes I don't like doing subtraction. I do addition, right? I was thinking in my head, I was like, oh, if I add 24 to this, that will take me up to 600. And then to go 600 up to 665, that's 65 more. So 89 total. So sometimes I actually do addition instead of subtraction. But I apologize if that was confusing. If not, just do regular subtraction. Now we have this remainder, but we don't use remainders with decimals. This says round to the nearest tenth. Well, this is a tenth. But remember, if I want to round to the nearest tenth, I actually have to know what this one is. Because if this one is a 5, 6, 7, 8, 9, then this will round up. If this one is a 0, 1, 2, 3, 4, then this one will just stay, right? We just chop it off. So here's what I do. I actually just add an extra 0 right here. Remember, you can put as many zeros on the end of a decimal as you want. We're just going to add another 0 there, bring it straight down, like that. And then we would say, how many times does 96 go into this? It's actually going to be 9 times, I believe. Yeah, it's gonna be 9 times. 54. Yeah, so it fits 9 times. But I actually don't even really care because the fact is this is 5 or larger. So when I go to round this, when I go to round this number, I'm looking at that one and I'm just going to turn this into 7.7 because I have to round to the nearest tenth. So make sure you're paying attention. Because that 9 is bigger than 5, or is 5 or larger, I should say, um, we're gonna round it. So it says round to the nearest tenth. That means we have to find to the nearest hundredth. We have to find the hundredths. That way we can round to the tenths. Okay, back up here in the next problem, and this is our last division problem. I can see I've got to move this 2 places to the right, so I'm going to move this one 2 places to the right. What I get is 47.3 divided by 54. Remember, I've got to get not just this one, but I've also got to get this one too. That way I'll figure out what this is, and then I'll figure out how I need to round this. Okay? So 54 doesn't go into 47. Right on. 54 does go into 473. 8 times, probably. Let's see. 32. That's 43. Yep, I think we're good with that. That's a 1 and a 4. And then the next thing is I'm going to bring, and remember, if this one was bigger than 54, I'd actually just go up and bump this up to 9. Okay. All right. So I'm going to add another 0 on right here because we can always do that when we're dividing with, and working with decimals. So this is 410 now, and 54 goes into 410 definitely more than 5 times. 6, 7, probably 6 times. 24. Ooh, that's 32. Oops. Nope, not 6 times. See, here's a great example of what I was just talking about, right? Because this is going to be, let's see, 76. This is going to be 86. So 86 is too big. 54 fits in here another time. Now, it honestly doesn't matter. I'm just kind of, it's almost like wasting time at this point. But, you know, I guess we might as well do it right. That's why we're here. So that one wasn't big enough, right? 54 went in another time after that. 28, 2, 37. Yeah. So this is better. And but the whole key to that is what the reason we were doing that is we were looking at this number. If this number is a 5, 6, 7, 8, or 9, then this number will be rounded up. And that's just the case this time. So we get 0.9 or 0.9 for this. Okay. All right. So this is decimal division. It's not easy. So make sure you get a lot of practice in. Go back and redo some of these other problems. Maybe if decimal division is hard for you, redo some of these same problems over and over again until you know exactly what you're doing. It's no use going on to other problems if you can't even do the ones that are already explained. So redo these until you can absolutely do them because you know they're right. Or at least I hope they're right. And if they're not, then I guess leave a comment or shoot me an email or something. Probably leave a comment. That way other people can get that figured out more quickly. All right, good luck.